Let's look at the question. Sort array by parity. We are given an integer array length, and we need to move all the even integer at the beginning of the array and followed by the odd integer. That means we need to move the odd integer to the end of the array, and then we just return any array that's satisfied with this condition. So now let's try a new method we call two-pass approach. First we get the input data here, and we set a for loop for I in range length A, and we can turn length A to the n, so it is easy when we analyze the time complexity, and we just use n here. So the time complexity will be O of n. So if I is a module 2 is a remind 0, then we just write something, or we need to create a new array to let's say a t to receive the data here, to receive the new element, to write in a new element, and need to initialize t is the index of the new array n's, and if it is then we just write the number in the even number in the here. We first write an even number here, and t is an increment. So let's try to out. We need to declare a new array as it's run out of index. It is empty. We need to create a space, like to use 0 to occupy the space for 0 for I in range length A. Say it works. So before that we can make a test print ends. So it occupied the length for 0, right? So we can print out here to see how it works. So now the first two 0 was be occupied by 2 and 4 because it is an even number. So let's write a odd element for I in range length n, and if A at I modular 2 reminder, let's say 1, so ends at t get the value from here, and plus, and so there are only once. If an integer number is modular by 2, there are only one situation. It's either remainder 0 or 1. It's not possible to be 2, because if it is by 2, it will become 0, right? So let's try to, it works. We first write the even number to figure out to write the even number, and then we write down the odd number. But actually we can try a better solution. Here we write a better solution. We don't have to create, because Python have a lot of abbreviation writing approach. Or like we can directly print create a list. We already create a list for x in A, if x modular 2 remainder 0, and we continue to add a element to the list x for x in A if x modular 2 is remainder 1, and we can print. Let's show the A here. So we already did it. We can make this into our function, right? Let's try it. class solution define sorted array by parity and self length and is integer list and return integer list 2 and this become a return and inside get them indentation and print them out. Solution dot sort that get them here. Oh, let's change it to A. Yeah, it's worked. If we really want to do this sort in place, we can use quicksort. It is a standard textbook algorithm. We will maintain 2 pointers, I and j. The loop invariant is everything below I is a parity 0. That means when k is less than I, the element at k multiplied by 2 is equal to 0. So the element is even, and the everything above the j has a parity 1 because the element is odd. Now let's compare the element at I multiplied by 2 and element at j multiplied by 2. Then there are 4 cases for them. The first case, if it is 0, 1, then everything is correct. We just increment I and decrement j. So I is moved from the left to right and j is moved from to the right to left. And the second case, if it is 1, 0, we just swap them so to make them correctly and we can continue. So the I is increment and j is decrement. So if the second case is if it is double 0, so that means only the I place is correct. So we increment I and stay the j in the same place and continue. And the fourth case, if it is a double 1, that means only the j place is correct. So we decrement the j and continue. Throughout all 4 cases, the loop invariant is maintained and the j minus I is getting smaller. So eventually, we will be done with the array sorted as we desired. So let's analyze the complexity. The time complexity is O of 1, and the n is the length of the A, and each step of the while loop, we make the j minus I decrease by at least 1. So while normally the quicksort is O of n times log n, but this algorithm is different. It is O of n because we only need 1 pass to sort these elements. So let's implement the algorithm in Python. First, we initialize I and j, these 2 pointers. The I start from 0 because they need to move from the left to right, and j is need to move from the right to left. So j is the last element. So it's length minus 1. So we need to give the boundary while to make sure the 2 pointer didn't move to out of boundary. I is always less than j, and so if I is equal to j, that means we reach the boundary, right? So if I at I modular by 2 is bigger than A at j modular by 2, that means A at I is a remainder 1 and A at j is a remainder 0. So 1 is bigger than 0. So in this time we need to move even element to the first part of the array and the odd element to the last part of the array. So A at I and A at j do a swap. So a at j and a at I. So because this time it is this is 1 0, we need to 0 1. All the parity is 0 1, right? 0 1 0. So this is 1 0. We need to change 1 0 to 0 1. So it is really easy to understand, right? And meanwhile, we need to always keep track of I is multiplied by 2 is 0. So make sure every time we point at the even number, we just increment them, move from the left to right. And if a at j is multiplied by 2 is remainder 1, that means all the number is j is decrement by 1, and then we finished. We just return a, and we can call it by print solution dot sorted, and we can get the example input here. Yeah, that will work. The even number move to the first part, and the odd number move to the second part. Yeah, we did it.